All right, good morning, everyone. My name is Roxann West. I'm the new segment or business development manager for Schneider Electric, and I have also here my colleague.
Good morning. My name is Jana Hermann, and I work as business development manager for green hydrogen in DACH region.
And today we'll be speaking about the critical role of digital and automation solutions for a competitive scale-up of hydrogen production. For those of you that are not familiar with Schneider Electric, so I'll give a quick, brief overview of what we do. So we are a technology company providing solutions for energy management and industrial automation to provide and enable efficiency and sustainability for our customers globally. We operate about at 36 billion revenue last year in over 100 countries worldwide with 136,000 employees worldwide as well. And so to begin, I want to briefly give an overview of the market update, specifically in Europe for green hydrogen. As maybe some of you are already aware, the European Union has set forth quite ambitious goals to increase the capacity of green hydrogen production domestically to about 10 million tons per annum by 2030. So it's quite ambitious goals with many challenges that I've listed here, including the dependency of government regulations to provide incentives to reduce the costs. And also in the recent years, we have increased costs fueled from inflation and rising interest rate, challenges such as also securing renewable energy, as well as guaranteeing the off-takers to secure funding to implement these projects. Last but not least also is development of the infrastructure to link the supply and demand. And I've listed here some of the enablers that can help mitigate or address some of these challenges, which includes some of the advancements in technology, particularly in the core process and for electrolyzers, the development of infrastructure that is critical, like I said, to link this demand and supply, as well as the scale-up, economies of scale. And last but not least, our focus for today's topic is the implementation and for digitalization and automation for the hydrogen production and implementation of the projects. Now, diving into the costs of the levelized cost of hydrogen, which I mentioned is one of the critical component that is a challenge to scale and implement green hydrogen projects. As you can see here, I have given an example of a sample of the variables of the levelized cost of hydrogen, many of which right now the projects are also being driven down as far as the cost with incentives from government policies. So how can we drive this cost down to make it more competitive and make it be a viable option compared to like natural gas, to drive that cost down to make it compatible to less than 2 euros per kilogram of green hydrogen produced. So we see one of the critical ways is to maximize this operational excellence by implementing tools, digital tools, and automation. So I provide here a recent study that was done by McKinsey that shows that the potential capex reduction can reduce to over 30% with technology advancement through 2030. This can include advancements in your electrolyzer technology as well as your overall balance of plant, with additional reduction that can also be realized with simplification and standardization of your design, and also your delivery design. And then an example here I showed that was taken also from a study, just to show an example from a green ammonia plant on how implementation of digital twin, for example, in your design and operational life cycle can reduce the cost, your levelized cost of hydrogen between 5 to 15%. tools such as digital twin, as well as the integration of AI, advanced analytics, predictive operational insights can help you realize these reduction costs that are very critical to make to scale and make green hydrogen viable for the future. So with that being said, we at Schneider Electric, we want to help you evolve and become the best-in-class developers. So what I have shown here is the classification of 4 stages to provide you the overview of the digital maturity that can evolve, and we want to help you drive to become the best-in-class developers with some of the solutions that are listed here. So as you can see, majority of the players right now are still in the beginning or maybe a slightly more advanced stage. And we want to drive that to become the best in class by implementing tools such as the digital twin model. For us, as we are an energy management as well as an industrial automation provider, we are able to also integrate these 2 data points between power and process to be able to provide you a unified view to further enhance and optimize your overall process. So I highlighted here 3 of the solutions that we will go further in the later slides, one of which is optimize operation through open automation to be able to enable you to bridge that gap between IT and OT integration, as well as tools, analytic tools to provide predictive maintenance and optimize asset operation, as well as the integration of power and process data to provide you this high fidelity digital twin model from your design stage all the way to your operational stage, incorporating real-time data to provide you a flexible and future-proof digital twin of your plant. So first and foremost, I want to show you the concept here of what we call the open software-defined automation. So over the last 50 years, we see that for industrial automation, we need to make it open to be able to integrate more IT capabilities and to also be able to enable our customer to provide the flexibility in terms of implementing and opening their vendor selection when it comes to control hardware selection. So what we have proposed is the decoupling of your software, control software, with your hardware, and building this independent application where then you can build your control system independently of your hardware selection. This makes it easier for you to select the different control hardware system, as well as bridge that gap to incorporate IT capabilities into your automation system to provide real analytics and further improve your KPIs for your operation. This will enable you to have a plug and produce a model, a more modular approach that can also accelerate your implementation of your projects. With this, we also founded a nonprofit organization called universalautomation.org that is helping to promote this ecosystem to recruit more vendors, end users, universities, and partnerships and collaboration to enable and grow this concept of openness. And with that as the kind of underlying foundation, we also want to take advantage of the computational advancements with AI and with process simulation to provide further insights for your process. So taking into account the data from past historical behavior to your current behavior to provide this predictive analytics, incorporating AI-driven models to help you detect failures and increase the time to failure estimates. And then in addition, incorporating your simulation models with our Aviva software solutions that can also increase the range of your anomaly detection and enabling you to have earlier intervention and greater risk mitigation. So this will allow you to give more predictive insight on to know what's going to happen next. How can you improve your production, your process insights, and how you should act, giving recommendation on how you can act and improve your overall process. And with this, we also have a collaboration effort through our co-innovation lab, taking the example what I shown earlier with open automation as well as integration of AI and advanced analytics to build a platform utilizing this open approach. So specifically looking into the electrolyzers. As you know, this is the core process of a green hydrogen production. So there are still a lot of unknowns. So we want to take these unknowns, incorporating advanced process control with advanced sensing in the electrolyzer stacks itself, and then taking that data both from a process and an electrical point of view, and providing that data and giving those insights to help you give recommendation or set points in the beginning, and then as you learn, as the data matures, to be able to give this more of a remote autonomous operation to enhance your efficiency and as well as elongate the lifetime of your electrolyzers. And last but not least is the digital twin. So one aspect that we at Schneider, I think it's a key differentiator, is we're able to provide this insight from your electrical input as well as your process. So by providing this integrated approach of process and power, you're able to, especially for green hydrogen production, where the electrical input is important, and it can affect your overall green hydrogen production. And also in terms of obtaining the renewable energy is not so easy, so you want to be able to maximize on what you have both from your energy input as well as your hydrogen input. So by combining these two, conceptually from your design to build this simulation, and then using the same digital twin for your operational, and also by using the same model to provide, for example, training simulation for your operators, you can make timely decision for your projects, right? Both economically on the CapEx and OpEx side. And just to give you an example here of what that looks like on the simulation. So as you can see here, we have a combined view taking the input from your electrical sources. So here we show the grid input from the renewables, for example, here on the solar, the photovoltaic power that's coming in, and how that impacts your production of your green hydrogen with the electrolyzer here. And you can take this model and also take this from, like I said, from your design conceptual state to do what if analysis, to be able to see your economics analysis, as well as taking this model to build this digital twin for your operational once you have the plant running for your operation at a later stage. And with that, I will hand it over to Jana, who will go in further deep dive for our energy management system.
Thank you, Roxann. So our energy management system is a way to optimize green hydrogen production in the operational side. So while we need to, or we want to use or orchestrate the use of renewable energy resources, the connection to the grid, while ensuring as high hydrogen production as possible. And with this tool, we are able to decrease the operational cost of the green hydrogen production, and while achieving low energy costs and by sustainable power consumption. So we use the latest AI technologies to evaluate dynamic parameters in short intervals, such as green energy market prices, also weather forecast, and the hydrogen demand on site. You can see in the right upper corner the cutting-edge web-based user interface, where you can see the energy consumption, savings, and CO2 emissions. And with these tools, we are able to achieve the predictive production planning. We use, or Schneider Electric is able to offer the systems for industrial green hydrogen production, so high scale, but also for middle size or for small size microgrid advisor, which enables the island or microgrid operational mode. And as an example where we applied this kind of system is our project, we say, in H2 power plant at Vilo Park Dortmund, which is an example of a project of an innovation with impact, as we like to say in Schneider Electric. And this is a solution for green hydrogen electrolysis produced from renewable electricity from, in this case, solar energy, converting purified rainwater to through electrolysis to green hydrogen. So in this case, we are able to produce up to 10 tons of green hydrogen per year, which is saved for further use. And Vilo wanted, or we can offer this solution together with Vilo as a containerized, standardized solution, which is then tailored to specific customer needs. So it is a modular system which can be then fitted to specific requirements. So here about the solution overview, you can see that the core of the system is electrolysis, and Vilo has expertise in water treatment, water purification, and water bearing systems, which are crucial for green hydrogen production. We can use, as I said, rainwater, which is highly purified, so we can use this water for the electrolysis process. As the renewable energy source, we use solar power plant, but it is also possible with wind or with the electricity from the grid. We have a battery storage which can buffer the process to avoid high pressure drops at a system run up or shut down, so we can ensure the longer lifetime of the electrolyzer. And part of the system is, in this case, low pressure hydrogen storage. It is also possible to implement a high pressure energy storage, which can enable us to use the hydrogen, for example, for transportation. And we can supply the green hydrogen for different production processes, through methanization or directly to the gas grid, or we can implement a fuel cell which can convert green hydrogen back to electricity in case of need, and balance electrical loads of the system, or use it further for e-mobility, or supply back to the grid in case it is economically sustainable. And here I would like to speak more in detail about what Schneider Electric supplied to the system. So especially regarding our system, our software solution. So we delivered the centralized control management of different system. It was important that the whole system is interoperable and that it can be integrated with the building management or with production processes, production systems of Vilo, which is the case. So our microgrid advisor is a solution which is orchestrating the different energy resources together with hydrogen supply. With hydrogen storage, and ensuring that the system is connected to the customer's power system regarding to his requirements, and also ensuring the low cost of produced hydrogen. And then we delivered also a connected automation solution which controls the process. So the electrolyzer, fuel cells, battery system, and hydrogen storage, all the valves, pumps, and so on. So including hardware, PLC, and the third part or third layer of our solutions are connected products. So the classic offer of Schneider Electric as the which is an energy distribution system. The whole solution is scalable, flexible, and open for modular expandability, both on the process side, on the Vilo side, as on the system side. And to conclude, what is the first step if a company decides to start a journey with green hydrogen? So it is important to set a clear strategy and timeline when you want to reach your goals. So in this regard, we are always happy to help in Schneider Electric with our consulting services. We can offer an end-to-end solution with energy and sustainability consulting, which is connecting the consultancy service together, tying up together with the end solution engineering, and we have a base of our design engineering tools together with Aveva, which is the world leader in operation. In optimizing operation and design software and industrial information solutions, and then our interoperable Schneider Electric platform for the automation solution for the power systems enriched by ETAP electrical digital twin, which helps or which enables to connect the power and process together. So, and the key takeaways from our presentation is that to optimize the cost and efficiency of the green hydrogen production, it is important to use the best-in-class and the modern operating assets and operating technology, and automation and digitalization play the critical role in mitigating risks, in scaling up the hydrogen production, and addressing the cost of green hydrogen. Last but not least, AI and digital tools integration can address the complexities of leveraged cost of hydrogen in reducing this, and by embracing of all of these technologies, we can address it is enabled to decrease the cost of hydrogen production, and also to ensure the competitiveness on the both national and global level, and also to enable this sustainable high or fast growing market, to enable the competition and the scale up and modularity regarding to the operational costs and also capex. Yes, so we will be happy if you reach out to us to discuss how you can make the best of your resources and energy, and happy for any questions.
Yeah, Jana and Roxann, thank you very much for this very impressive and interesting presentation. So are there any questions from the audience? We have plenty of time, and we can hand out microphones, so no issues, to make sure that your questions can be asked now live on stage, or later on you can also go to the speakers. Yes, there's one question. Thank you very much.
Thank you for the presentation. I would like to know whether the system takes into account the purity of the hydrogen in order to apply it for the other applications.
So you mean the wheel power plant system, or the system for hire for industrial scale applications?
For both.
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 Yes. So we are trying to make our best, especially therefore we were mentioning our consulting services, because every solution can be very different and specific to customer needs. So if we can support as soon as the journey starts, we can address all the different use cases and help to define them in order to choose